Bismillahirrahmanirrahim. Assalamu alaikum students. This is Hamza Noor from Aero Education Network, and in today's video I'm going to discuss some questions from International A-Level Edexcel M1 exercise 3D, some particular exam style questions from the textbook, chapter number 3, Vectors in Mechanics. So first of all, we have the question number 9, which says that at 2 p.m., the Coast Guard spots a rowing dinghy 500-meter due south of his observation point. The dinghy has constant velocity 2I plus 3j meter per second. The requirement of part A is to find, in terms of t, the position vector of the dinghy t seconds after 2 p.m. So initially when t is equal to 0, the time is basically 2 p.m. So after 2 p.m., we need to find in terms of t the position vector of dinghy t seconds. Okay, t seconds after 2 p.m. So as we know the fact that this dinghy at 2 p.m. the Coast Guard spots a rowing dinghy 500-meter due south of its observation point. So let's say this is the observation point, which is point O. This is basically the origin. So 500-meter due south means 500-meter vertically downwards from point O. Let's say somewhere over here. Okay, at time t is equal to 0, the dinghy is over here. All right, and the Coast Guard observes this dinghy. So we are going to say that this is minus 500j. The initial position vector of this dinghy, which is related with the origin, is minus 500j. I component is 0 because this is due south of the observation point. Okay, and the dinghy has a constant velocity of 2I plus 3j meter per second, meaning the constant velocity vector tells you the path of the motion. It tells you the direction of motion, meaning the dinghy is basically going in this path, 2I plus 3j, meaning horizontally 2 units towards right and vertically 3 unit upwards, 2I plus 3j. Okay, so the path of motion of the dinghy goes something like this. All right, the dinghy goes in this path. Okay, so what we need to find in terms of t the position vector of the dinghy t seconds after 2 p.m. So as we know the fact that the basic equation for vector is r is equals to r naught plus vt, where r is basically the position vector at the time other than t is equal to 0. Okay, and r naught is basically the position vector at the time t is equal to 0. Okay, so r is equals to what? R naught is basically simply minus 500j because I component is not there. So r naught, in place of r naught, I'm going to write minus 500j, and the velocity vector is basically 2I plus 3j meter per second. So 2I plus 3j times t. Okay, so therefore I'm going to say that the I component is 2ti. So r is equals to 2ti and then uh, 3tj minus 500j. So j component is basically 3t minus 500. So r is equals to 2ti plus 3t minus 500 completely multiplied by j. All right, so basically at any time other than 0, which we can say time t is greater than 0, okay, where t is unknown. So the position vector of the dinghy is this. R is equals to 2ti plus 3t minus 500 into j. The I component is 2t and j component is 3t minus 500. This was a requirement of part A. So now we have part B. So part B says that find the distance of the dinghy from the observation point at time 2:05 p.m. Okay, so 2:05 p.m. means that after 2 p.m. we are talking about the 5 minutes. So t is equal to 5 minutes. However, the constant velocity vector is given to us in meter per second. Okay, so if I say 5 minutes, so this essentially means that 5 multiplied by 60, meaning 300 seconds. So I'm taking the time in seconds. basically because the velocity vector is given to us in meter per second. So 25 pm means we need to keep t is equals to 300 over here. Okay, so here I'm doing the working for part B. T is equals to 300 seconds. So what we need to find? We need to find the distance. So first of all, I'm going to find the displacement vector in terms of I and j. Because what we need to find the distance from the observation point, meaning the distance from the origin. Okay, so first of all, we will substitute t is equals to 300 seconds over here. So r is equals to, the I component will be 2 times 300 and j component will be 3 times 300 minus 500. Okay, so r is equals to 600 I and 3 times 300 and then take away 500, so 400 j. All right, so r is equals to 600 I plus 400 j. This means that from the observation point, from the origin, what we have is something like this, that the I component is 600 and j component is basically 400. Okay, so our dinghy is over here when t is equals to 300 seconds, meaning at time 25 pm. So here we have found the displacement vector, and now we are going to find this distance over here. Okay, so in order to find the distance, we will take the magnitude of this displacement vector. Okay, so I'm going to find the magnitude of 600 I plus 400 j, which is supposed to be under root of 600 square plus 400 square. Okay, so 600 square plus 400 square, this is supposed to be 520,000. So under root of 520,000. So under root of this thing is basically 721.11. Okay, and correct to three significant figures, 721 meter will be our answer. This is basically the distance as per the requirement, the distance of the dinghy from the observation point at time 25 pm. Okay, so this was basically the question number 9 of exercise 3D. All right, so after this we have question number 10 of exercise 3D. So the question says that at noon, a ferry F is 400 meter due north of an observation point O, moving with constant velocity 7I plus 7j meter per second, and a speedboat S is 500 meter due east of O, moving with constant velocity 23I plus 15j, but this vector is incorrect in the question. So you just need to make a correction over here that this vector is minus 3I plus 15j. The I component is incorrect. And why is it incorrect? I'll just show it and I'll prove it, okay, along with the solution of this question. But for the time being, just make a correction over here that the constant velocity vector for the speed boat is minus 3I plus 15j meter per second. So the requirement of part A is to write down the position vectors of F and S, meaning the ferry and the speedboat, at time t seconds after noon. Okay, at noon, basically, at noon, time will be equal to 0. T will be equal to 0. Okay, so after noon, we need to tell the position vectors of ferry and the speedboat in terms of t. So here we have the observation point, let's say point O, the origin, and it says that at noon, a ferry F is 400 meter due north. Due north means vertically upwards. So the ferry is 400 meter due north of point O, meaning the R naught, the initial position vector for the ferry is basically 400J, meaning the I component is 0. Okay, so 400 meter due north means the initial position vector of the ferry is 400J. And at the same time, a speedboat is basically 500 meter due east of the origin. So as we know the compass, that north south, east, and west. East is on the right. Okay, so due east means that horizontally from the origin we have a distance of 500 meter. So this is 500 I. So 500 I is basically the initial position vector of the speedboat, meaning R naught of the speedboat is 500 I, meaning the J component is 0. So we need to find the position vectors of the ferry and the speedboat. Okay, and they are moving with the constant velocities. So ferry is moving with a constant velocity of 7I plus 7J, meaning the ferry is over here initially. So the path of motion is basically 7I plus 7J. Since the constant velocity vector is given to you, so horizontally this ferry uh, is going 7 units, and vertically the same units, meaning 7 units. So 7I plus 7J, this is basically the path of motion. In this path, the ferry is moving. All right. And as far the speedboat is concerned, so we have made a correction over here for the constant velocity vector. This is minus 3I plus 15J. Okay. Minus 3I plus 15J, meaning horizontally 3 units towards left and vertically 15 units above. Okay. In this path, the speedboat is traveling. All right. The constant velocity vector tells us the direction of motion of the object. So now for the ferry, R is equals to R naught plus V times T. So R is equals to what? R naught is basically 400J. So 400J plus 7I plus 7J times T. Okay. So R is equals to, this means that 70I plus 400J plus 70J. So far we have achieved this thing. So R is equals to 70I plus, taking J as common, multiplied by 400 plus 70. So this is basically the position vector for F at time t seconds after noon. The position vector for ferry. And now in the same way, we are going to find the position vector for the speedboat. Okay, so for the speedboat, for the object S, R is equals to R naught plus V times T. Okay, so R is equals to, in place of R naught, we have 500 I, and the constant velocity vector over here is minus 3I plus 15J. Okay, and then R is equals to 500 I minus 3Ti plus 15Tj. So this means that I component is 500 minus 3T. Okay, by taking I common, multiplied by 500 minus 3T, and then plus 15Tj. So this is supposed to be our answer to part A, the position vector for ferry and the position vector for a speedboat. All right. And now in part B, what we need to show that ferry and a speedboat will collide, and we need to find the position vector of the point of collision. So here I'm also going to prove that the original information which was given to us in the question, that the constant velocity vector of the speedboat is 23I plus 15J. Why it is incorrect? Because if we use that 23I plus 15J, so we would not be able to show that the ferry and the speedboat will collide. Okay, so first I'm going to solve this question according to the amendment, according to the correction which we have made over here. Okay, and then I'm going to prove that thing, that why it was incorrect, the original information of the question. So here was the solution for part A, and now we have part B. Okay, so we have the position vectors for the ferry and the speedboat in terms of t. Okay, so if they collide, if the ferry and the speedboat collide, so they will collide each other, they will intersect each other, they will meet each other at a common point. So that particular common point, on that common point, I'm going to say that the OF vector and OS vector are equal to each other, meaning the position vector of the ferry and the position vector of the speedboat are exactly the same because they have a point of collision. Okay, so what I'm going to do, I'm going to equate these two vectors with each other and I'm going to get the same value of t. Okay, so I'm going to say that the position vector for the ferry and the position vector for the speedboat are same. So we are going to say that 70i plus 400 plus 70 into j is exactly equals to 500 minus 3t into I plus 15tj. So when these two vectors are equal to each other, so the I component is equal to the I component and j component is equal to the j component. So equating the I components with each other, I can say that 7t is equals to 500 minus 3t. So this means that 70 plus 3t is equals to 500. So 10t will be equals to 500, meaning t will be equals to 500 divided by 10, meaning t is equals to 50 seconds. So now I'm going to get the same value of t when I equate the j components with each other. Okay. So when equating the j components with each other, we are going to say that 400 plus 7t is equals to 15t. So this means that 400 is equals to 15t minus 7t. So 15 minus 7 is 8. So 400 is equals to 8t, meaning t is equals to 400 divided by 8, which will give you the same value of t, which is 50. All right. So if we used the original information of the question, which was an incorrect vector 23i plus 15j, you would have seen that if you use that vector, so the ferry and the speedboat will not collide. Due to this reason, the information which was given to us in the question was incorrect. So it's possible that there might be a typo in the question. So we have made the correction according to that. So t is equals to 50 and t is equals to 50. This is the value of t, okay, which is the same. And at t is equals to 50, we would be getting the point of collision. So in order to get the point of collision, either you can substitute this t is equals to 50 into the position vector of the ferry, or you can put it into the position vector of the speedboat. Okay, so since we are getting the same value of t, we are going to say that therefore the ferry and speedboat, the ferry and speedboat will collide at t is equals to 50. Okay, and we also need to find the position vector of the point of collision. So either you can substitute t is equals to 50 into the position vector of ferry or the position vector of the speedboat. I'm going to substitute this into the position vector of speedboat. You can substitute it into ferry. So 500 minus 3 times 50. This is basically the I component, and j component is 15 times 50. So in this way, we will get the point of collision. So 500 minus 3 times 50, this is 350. So 350i plus 15 times 50, this is 750j. So 350i plus 750j is basically the point of collision. In this way, we have answered this question. 350i plus 750j is the point of collision. So now I'm going to give some explanation over here that why 23i plus 15j was incorrect. One reason is that, if you used 23i plus 15j, you would not be able to get the same value of t by equating the I and j components with each other. And the other thing is that if you used this 23i plus 15j as the constant velocity vector for the speedboat, so this essentially means that when initially the speedboat was over here, due east of origin, 500 meter. So 23I plus 15J means horizontally you are going 23 units. Okay, and vertically you are going, 15 units. Okay, so 23I plus 15J, if this was the constant velocity vector of the speedboat. Okay, so now what you can see that, this line, the path in which the speedboat would have been traveling, the gradient would be, the change in y over change in x, meaning the rise over run. So you can say that the gradient of this line would be 15 divided by 23. So what is the value of 15 over 23? This is 0.652. Okay, this would be, the gradient would be 0.652. However, for the ferry, the gradient would be 1 because change in y is equal to the change in x. Okay, so the path of the ferry, this line has a gradient of 1 and this line has a gradient of 0.652. So basically, the line for the speedboat is flatter as compared to the line of the ferry. Okay, as you already know this, when the gradient is closer to 0, the line becomes flatter. The line is closer to being horizontal. So the line for the ferry is something like this. Okay, assume that this is point F, the initial position vector for the ferry. Okay, and here you have the initial position vector of the speedboat. Okay, so the line for the speedboat would be flatter. So if we used that 23I plus 15J vector for the speedboat, so you would have seen that the ferry and the speedboat would never be able to meet each other. Okay, and due to this reason, 23I plus 15J as the constant velocity vector for the speedboat is incorrect. And according to the correction which we have made, the constant velocity vector is minus 3I plus 15J meter. And you are able to see that at one point, they will collide. And one point, they will be colliding each other. They will be intersecting each other. All right. So in this way, we attempted this particular question. All right. So this was basically the question number 10 of exercise 3D of the textbook. Inshallah, I'll be uploading more videos. So stay tuned to my channel. Thanks for watching.